Uh, okay, so we start the session by solving this problem, which was left from the previous session. So if you remember, this was that was the previous session, and the final thing that I mentioned before explaining this example was this formula. That I called it a theorem, but this is a problem in your book. Okay, so you can use it if you want to, but of course I can solve the problem without using this one as well, but it means that I am just rediscovering the formula in that way of solving. So it would be a good idea if I can copy this so that you have it in front of your eyes. Copy. So here, let me just paste it here. So that is our formula, and let me make it a little bit smaller and put it here because I want to change the letters. Yes, here I am talking about biology, physics, and chemistry. Probably it would be better to call them capital B, capital P, and capital C for the first letters of these subjects. Okay, so what you know, assume that first of all you have this formula, because this formula I don't think it is in the formula sheet. Okay, so let me first solve this using this formula and then tell you that if you don't know the formula, how you can solve this. Okay, so assume that we know the formula. Even if you know the formula, it is always instructive to draw a Venn diagram for yourself based on the information given in the problem. So here, let me make the picture a little bit bigger here so this is, for example, the whole students. There are 380 students here, and then the subjects are biology, physics, and chemistry. And when you continue reading the problem, you can see that. So let me read the problem. In a school with 380 students, 250 are taking biology, 173 are taking physics, 182 are taking chemistry, 72 are taking biology and physics, 90 are taking biology and chemistry, and 60 are taking physics and chemistry. If 9 students don't have any of these courses, how many students are taking exactly one subject? That's the problem. And when I read that 72 are taking biology and physics, 90 are taking biology and chemistry, and 60 are taking physics and chemistry, it means that all these sets have something in common, yes? So it means that, for example, I will draw a circle representing, for example, the first subject, which is biology in this case. But if I want to draw a circle, for example, to represent physics, because I know that physics and biology have some intersection, so I don't draw it here. Because if I draw it in this way and put it physics, then it means that I am telling you that there is nothing in common. There is no students taking physics and biology, which is of course not true because there are many students taking physics and biology simultaneously. So this tells me that if I want to draw a picture for physics group, oops, let me make it a little bit bigger because then you will see this part becomes important. So let me take it in this way. I will call it physics. And for the same reason, when I want to draw something for chemistry, I need to draw it in a way that the circle intersects with both blue part and this red part, physics and biology, yes? So let me just make it a little bit bigger here so that I can put numbers in. So this is also chemistry. Okay, so first of all, I just want to mention that, for example, you are not allowed to draw something like this, because if you draw something like this, this means that there is no intersection between this set and this set. Or you are not allowed to draw something like this, because if you draw something like this and call it biology, physics, and chemistry, of course, physics and chemistry have something in common, physics and biology have something in common, but in this picture, biology and chemistry doesn't have anything in common, which is not according to the problem, okay? So the most general picture that you can draw is something like this. Okay, so I want to write this formula that you see here. I want to write this formula that you see here. This tells you that the number of elements in the union of all these sets is equal to this. But of course, this is more natural to work with capital B, capital P, capital C instead of A, B, and C. So let me just write this here for you. So I would write that the cardinality of the union of these three sets, biology, physics, and chemistry, is equal to the cardinality of the first one plus the cardinality of the second one plus the cardinality of the third one minus the cardinality of intersection of pairs of them. So B and P minus the intersection of B and P. So that I can write B and C, and then the intersection between P and C, and finally plus the intersection of all of them simultaneously. Yes, B intersection P intersection C. So here my solution relies on knowing this formula. Okay, so let us assume that we know the formula for the time being. Okay, so what can I see? I know that there are 380 students in the unit circle in this school. In this big rectangle as the universal set, but 9 of them are not studying any of these subjects at all. So it means that how many people are here? So I can write 9 students are here. And then what is left is 380 minus 9 is 371, yes? So 371 students are somehow distributed inside these circles. So this tells me that the cardinality of the union of these three sets is equal to 371. So let me plug the numbers that I have. So instead of this expression, this tells me that the number of students inside all these regions that you see is 371. If you have any questions, please interrupt me. 371. On the right-hand side, this tells me how many students are in the biology group. Okay, but when I read this, I read it in this way. You see 215 are taking biology. So it means that the number of students that you see in this blue circle is 215. So I would write 215 plus the number of students in the physics group, 173 are taking physics. So this becomes plus 173. And then how many are taking chemistry? It is 182. And then minus the intersection between biology and physics. This means that the people who belong to this set and to this set simultaneously. So what does it mean? It means that if a person is in this set, it means that that person is taking biology. If the person is in this set, it means that that person is taking physics. But when I say intersection between these two, it means that I am interested in those people who are taking both biology and physics simultaneously, and I want to count the number of those people. And this is mentioned in the problem to be how many? 72. Biology and physics. So biology and physics is 72, so it becomes minus 72. And then biology and chemistry is given to be 90. Please correct me if I am making mistakes. And then minus physics and chemistry is 60. But the point is that I don't have any information regarding the number of people who are taking all these courses simultaneously. Yes, so this is unknown. Okay, but that unknown can immediately be calculated. So if you don't mind, let me, and that is a very good way, let me put this x here. So what do I mean by x? I mean the number of elements inside this. If I ask you what is this one, you say that this is the intersection, this is the points which belong to all of these three sets simultaneously. Okay, so I hope that this is clear now for you, that I can write an x at the end. Is this equation here that I have written clear for everyone based on the reading the problem? Okay, so this is a crucial thing. Usually this is very, very helpful in these kind of problems. Even if you don't know the formula, you start putting an x here and then start reading the problem. I will come back to it again. So let us just continue this solution. But this is a very, very simple equation. What I need to do is just to calculate these numbers. Okay, so let me be patient and do this. So I would write 371, and then let me use my calculator. So the calculator, I will add 215. Oops. 215 plus 173 plus 182, and then minus 72 minus 90 minus 60. Okay, so all these numbers, if I haven't done something wrong, hopefully the answer to this, I use my calculator, the answer is 348. And then, of course, I have an x at the end. But then if I want to find my x, I move this number to the left-hand side. So it becomes 371 minus 348. And this means that, okay, x is 23. So you see, this information helped me to find the number of students in the intersection of all these sets. Okay, now let us see what is wanted. How many students are taking exactly one subject? So this is clear. Where are they? Yes, the people who are inside this part in this region that I am hatching here. These people are the people who are taking only biology. They are not taking physics. They are not taking chemistry, because this is in the biology set, but outside the physics set and the chemistry set. But how many students are taking exactly one subject? That subject shouldn't exactly be biology. It could be physics or chemistry. So it means that we also go here. I need to count the number of students here. These are the students who are taking physics only. And then finally, these are the students who are taking chemistry only. If I can find the number of people in these three regions, then of course it is clear to answer the problem. I have to add these numbers together. Then I will get an answer to the problem. From conceptual point of view, is everything clear?
Yes.
Okay, good. So that's the point. I need to understand how to find, for example, let us concentrate here. So what I want to say is that when I know that this is 23, I can immediately know that how many people are here. Yes? How can I understand that?
Mr. Babak, I
Yes?
think there's a typo.
What?
I think there's a typo when it says x equals 371 minus 378.
Yes.
So
Okay, thank you. That's
348.
not, yeah, thank you very much. That is not 378. The answer is correct, but this is 348. Yes? Is that what you mean? Yes?
Yes.
Okay, so but the answer is correct. I did it correctly because I did it with calculator. So yes, the answer is correct. Okay, now if I ask you how many people are here, this is easy because I know the whole people in the intersection of biology and physics. Yes, how many of them are there? Biology and physics. 72 of them are taking biology and physics. So in this part, there are 72 people, but 23 of them are here. So how much is left for here? Yes, it is clear. So you need to write these numbers there. So what is the number here? The number here is 72 minus 23. Yes. But let me clean this because I can just write it. Yes, it is easier. But you understand what is going on. So here, 72 minus 20 is 52 is 49. Yes. So here is 49. Now, the same thing I can do here. If I want to, if I want to find this, how many people are here, I go and look at the intersection of biology and chemistry, and then I see that biology and chemistry is 90 people.
Man vet aldrig.
Yes, but 23 is here. I need to write 90 minus 23, yes, which is 67. So this becomes 67. And then I go here to find this part. This part, I need to consider the intersection between physics and chemistry. But physics and chemistry, how much are there? 60. Physics and chemistry. 23 of them are here. So 60 minus 23 is 37, yes. So I write 37 here. And I can also make it clear that this is 23. Okay, now can you tell me how should I calculate what is inside this part now? You see, it is very clear, it's not hard at all. Which information I need now? Yes?
215 minus 49 minus 23 minus 67.
Yes, exactly, exactly. So let me, I don't know how to write it so that you can refer to it in the future. So let me, for example, choose this dark one. So let me call this one, I don't know, X. Let me call this one Y, and let me call this one Z. Okay, now if I ask you what is the cardinality of X, as you said, the total number of people in the blue circle is 250. Those are people who are taking biology. But I have 23 of them exactly in the middle, 49 of them there, and 67 of them here. So if I use my calculator once more, the answer is 76. These are the people who are taking only biology, none of the other two courses. But then I can similarly calculate, yes?
You already used X as like the middle. It will be confusing.
No, so this is the capital X, yes, but you are right. I am not allowed to use the same letter for two things. But I don't know, hopefully you can differentiate. This is X and this is X, yes? Yes, okay?
Yes, yeah, okay.
I'm just using capital X, sorry for that if you're confused, but you are completely right. I am not allowed to use the same letter for two different things. Okay, so hopefully this is recognizable. This is a small x and this is capital X. And then I would write capital Y here now. The cardinality of capital Y is equal to. So here I need to go to the physics part. How many people are taking physics? 173 of them are taking physics. Then I subtract these things to find the people who are taking only physics. So it is 173 minus 23 minus 49 minus 37. So let me just do that. 173 minus 23 minus 49 minus 37. This becomes 64. And finally, the cardinality of that set Z is equal to how many people are studying chemistry? 182. So I have 182 minus 23 minus 67 minus 37. And if I calculate this, it is 182 minus 23 minus 67 minus 37. And that answer is 55. So the answer to the problem, the question mark, I hope that you agree with me. This is the cardinality of set X, the cardinality of set Y, and the cardinality of set Z. So if I add them, it becomes 76 plus 64. How much is that? This is 100. So it's, sorry, let me write plus 55. And this becomes 195. No calculator is needed, actually. So the answer to the problem is 195. So this is the nature of this type of problems. If you have, of course, if you have only 2 sets, it is very, very simple. So a little bit complicated questions are related to the cases that you have 3 sets involved. Okay, but if you have forgotten the formula, so if I want to do that, what I should do, I will, of course, that would be a little bit more tedious, but that is not hard at all. So here, what I can do, yeah, I should have copied and pasted one of them. Okay, so let me draw a quick one immediately here. So if I don't want to use, of course, it means that you are rediscovering the formula, okay? So if I take this one, then you will take here to be, for example, the biology group, and then you will take up, let me change the color, what was that? So let me, for example, take it like this, physics, and then you will have another color to here. This is chemistry. You draw something like this. Then again, if I want to solve this problem, I will, if I have forgotten the formula, I will start from putting an X here, and then I start reading the questions to write every part in terms of X. Okay, so for example, here, of course, it becomes tedious if you don't know the formula. So here I will go back here and read the question. Assume that you don't want to use the formula you have forgotten. So you will say that this is X, and then I know that the intersection between biology and physics. So where is biology and physics? So biology and physics are 72. So if X is here, it means that this is 72 minus X here. Yes, and then again, what is biology and chemistry? So if you go biology and chemistry is 90, if X of them are here, so what is left for this portion is just 90 minus X. And then I go for physics and chemistry. For physics and chemistry, where is that? Physics and chemistry is 60. Yes, so and then this becomes 60 minus X because X of them is already there. So this means that I have all these portions, but the bad point is that you also need to write something here, but of course, oops, this is X. So then you need to find something for here, this part. But that's not hard again. So if I call this one again as before, so let me just do that. If I call this capital X, oh, this color is too, yeah, this one. If I call this one again capital X and then capital Y and then capital Z, if I ask you what is the cardinality of the capital X, you cannot immediately answer that, but you can write it in terms of X. You would say that this is the total physics people are 215, and then you have minus 72 minus X, minus 90 minus X, and then minus X. Yes, and then if you calculate this, it becomes 215 minus 72 plus X minus 90 plus X, and then you have a minus X. So then this becomes how much you need to calculate. So 215 minus 72 minus 90, yes, these are the only numbers. It is 53. And then one of these X's and this X are canceled, so it is plus X. And this is your cardinality of this set. Or I don't know, might be there is also a better way you can think about yourself. So this is not a very strange problem. You can have your own way of solving the problem. Okay. And then you do the same thing. I don't know if I want to solve this again. So you can do the same thing for Y. You can do the same thing for Z. What happens? What happens is that what you get is everything in terms of X. But then after that, you know that the sum of all people here is 371. Yes, it was 371. Using that, you can find X. Yeah, let me solve this one for you. Of course, this would be boring, but anyway. So that is the the cardinality of x. Let me just do the cardinality of y again. So this is the way that I really don't need to use any formula. So remember, start by putting x here and try to write everything else in terms of that x using the information in the problem. So let me solve it for you. So what is y? I need to go to see how many people are studying physics. The people are studying physics is how much? 173. Then I subtract 72 minus x minus 760 minus x. Do you agree with me? The whole people here is 173. I want to find this part, so I need to take this one, this one, this one away. Yes, that would be this one. So if I calculate this, so let me write just the answer here. So this cardinality of y, so let me use my calculator, 173 minus 72, and then minus 60 is 41. And then you have positive x, negative x, positive x. So it becomes positive x. Yes? And then what we do, let us do the next one as well. So the cardinality of z is equal to the number of people studying chemistry, which is 182. And then I have minus these parts, this part, this part, and this part. So it is minus 60 minus x minus 90 minus x. Okay, so this means that the cardinality of z is equal to, if I use my calculator again, it is 32 and then positive x. Yes? And now what you know is that if I add all these parts is supposed to be 371. And the good point is that in all of them, I have one unknown, and that is x, so I can find my x. Okay, so let me just do that here. So let me write. I start from here. Cardinality of x is this number, so 53 plus x. Then I have 72 minus x. Then I have x. Then I have 90 minus x. So be careful, do not count two times, yes? So everything here is now gone. I have cardinality of y, but cardinality of y is 41 plus x. So this becomes 41 plus x. And then what is left? Only this one is left. Do you remember? Because I calculated all of them before. So 60 minus x is left. Yes, 60 minus x is left. And then plus, what is left for me is the cardinality of z, which is 32 plus x. This is supposed to be 371. And if you don't mind, let me just calculate these numbers. So what I am doing, first of all, how many x's are left? This one and this one are gone. This one and this one are gone. This one and this one are gone. So you see that I am left with one single x. Then I add these numbers, 53 plus 72 plus 90 plus 41 plus 60 plus 32. The answer is 348. You see, that is the consistent with the previous one. So this becomes 348 plus x is 371. Yeah, it is a mess, so let me make it clear here. So this implies that finally, let me write the answer. It's 23, and that is exactly consistent with what I have done before. But here I am not using any formula. Of course, it becomes more tedious, but I am not using any formulas. If you can somehow have this in your memory, use it, that's okay for me. Okay, and then when this is 23, the good point is that now, let me change my color here. So I can put this back here. I can put this here. I immediately get the cardinality of x. So this implies that cardinality of capital X is equal to 23 plus 53, which is 76. And then here, this implies that the cardinality of y is 23 plus this one is 64. Yes. And then here, this implies that the cardinality of Z is 55. And then you immediately see that these numbers that I have got are exactly these numbers, which I was able to get much simpler. Of course, the price is that you need to use your memory, okay? Is that okay? And now I think, Khulud, you can answer that question yourself. Do you think that you will have some problems there? Because I couldn't translate it exactly the words, but I think the idea is the same. Don't you think so?
Yes, I saw what I did wrong. I never subtracted x from the whole, like,
Okay.
and y in the question. But I have
Okay.
a question.
Yes.
In the test, will you give us this theorem, or do we have to memorize it?
No, because according to the rules, I can only give you the formula sheet, yes?
Can't you do
And
it
if you see this
as
problem
a-
is a problem, as you said, this is a problem in the book, similar to a problem in the book. So either you have to memorize it or use it in this long way, yes?
So you can't give it as a
No, I can give it. I don't think something will happen
yeah,
in the
because if
world.
we know how to use it, then we know how to use it. Like, instead of
No,
memorizing.
because the reason that this part is given, by the way, you see that this is not a formula in the body of the book. Yes, this is just a formula in one of the problems. So this in its own is a problem in the book. The reason that I express it as the theorem, that because I know that when I want to solve these kind of problems, if I don't want to use the theorem and start everything from scratch, which I really don't like to, then I have to spend a lot of time and effort to do that. So either you have to improve your memory or I don't know, you can start everything from scratch. We can talk about these things later, okay?
Okay, yeah.
So don't worry about the exam for the time being, because we also need to do something for the first exam, because I think might be some of you are not. So you just study with me. If you are coming to my lessons, you need to just think about mathematics, okay? And then we can, of course, it doesn't mean that be lazy and don't work. You have to work a lot, but you need to concentrate only on learning mathematics. Then the grades will come automatically later, okay? And then I told you that most of the time I do not evaluate you just based on what you write in the exam paper. I also evaluate you from this, from the way that I know you. By the way, even if you solve one single problem in the exam and that is correct, that gives more information to me about your math knowledge than just that one problem. The way that you express yourself, you write your solutions, how organized you are, all of these things, I can use them to evaluate you. So this is why I'm saying that in my lesson, just be worried about learning math. We can come talk about those things later, okay? Okay, so hopefully this is clear for everyone. There is one small part which is left. I don't know, for some reason the book has chosen it to put it under the title of combinatorics. I can understand why, but I will prefer to put it under the title of set theory. Okay, and that's a very, very small thing. I will just talk about that and we are done. And then next time we can start the very fascinating and interesting subject of combinatorics. Okay, but again, I don't know why. Again, there is a lot. So I will talk about this later. Okay, so here I just want to start a new topic, which is very short, and hopefully we can finalize it today. And that is the notion, because so far we have learned 3 operations between 2 sets. And 1 operation for 1 set. That 1 operation on 1 set was called complement, making a complement set. But then we learned if I have two sets, I can union them, I can intersection them, and then lately we learned how to subtract them. Yes, there is another operation between these 2 sets. Between 2 sets, it's called the Cartesian product. Okay, so Cartesian product. So this is why I prefer to put it under the title of set theory, yes, instead of putting it under the title of combinatorics. And that's a very, very, of course, this would be a very interesting topic in its own, but the book has just defined this, that's it. So you need to know what the Cartesian product is and how to just determine it for a very simple if two simple sets are given to you. But before that, let me just define you the notion of an ordered pair. And I want to motivate you because do you remember, I want to motivate you a little bit why we need this concept. We already know about this a lot. So here, if you remember, the set doesn't respect the order. So if I have a set of two elements A and B, say, okay, let me write numbers because let me write 1 and 2. If I have a set consisting of two elements 1 and 2, this set does not distinguish between this and that one, yes? So when you say that I have a set consisting of two elements, it doesn't matter at all if you write it 1 and 2 or 2 and 1. In other words, the order that you write the elements in a set is irrelevant, yes? You don't need to be, so it means that these two sets are equal. But sometimes in mathematics, we need to consider the order in which these elements are coming. So I cannot use the order, I cannot apply the order on two elements by putting them in curly brackets. Because if I put them by curly brackets, it means that I am not respecting to the order at all. But on the other hand, from very elementary lessons, you know that sometimes order matters, yes? For example, if I have this coordinate system, if I write a point A with coordinates 1 and 2, where is this point? This point, the x coordinate is 1, the y coordinate is 2, so this point is here. So this point is this point. But look, if I just change the numbers, keeping the numbers the same, but I change the order, yes, then you will get a point 2 and 1. This point is no longer the same point. I have to call it a new point. Why? Because this time the x coordinate is 2, the y coordinate is 1, so this is the point B, yes? So immediately you realize that the order matters here. The numbers are the same, 1 and 2. Here 1 and 2, here 1 and 2, but the order are different. The orders are different. So, and then the consequence would be this, will not be the same. So sometimes in mathematics, order is not important. For example, assume that I want to choose two people and then give them, I don't know, a banana. And the bananas are completely identical. So here, it doesn't matter in which order I choose those people. For example, if I choose Alex and Holudor for some reason, and then it doesn't matter at all the order I am choosing these people. So sometimes in mathematics, order does not matter at all. Sometimes in mathematics, the order matters. If I don't consider the order, if order is not mattered for me, I can use the notion of curly brackets and the notion of a set. But if the order matters, this is not a set. So I need to have another concept in mathematics, and that is called the ordered pair. This is very, very natural concept. So I would say definition. Yes. I would say that any pair of objects for which the order of objects matters is called an ordered pair. Okay. The objects are called the first and second components, of the ordered pair. Okay, so here, and the way that I denote the ordered pair is I put a pair of brackets around the objects. Yes, so this is an ordered pair whose first component I call it little a, and a second component I call it little b. Yes, so this is the first component, and this is the second component. Okay, so for example, here in this context that I am working with numbers, order matters. So this is was the reason that we put pair of brackets around them. So this is an ordered pair whose first component is 1 and its second component is 2. This is also an ordered pair whose first component is 2 and the second component is 1. Okay, so that is nothing at all. You have a pair of objects in which the order matters. And then there is also definition, so definition of equality of these two. And that is also clear for you. When do you think that two ordered pairs should be equal? I want to define it, but what is, you can immediately realize what is the suitable definition for equality of two ordered pairs, yes? Can you tell me when it is suitable to call two ordered pairs equal?
When the first component equals the first component of the other pair, and the second component is equal to the second component of the other pair.
Exactly, because
component, yeah.
Yeah, exactly. Because if you want to have these, because when I say that these two ordered pairs are the same, so it means that I shouldn't be able to distinguish between these 2 points. So it means that these 2 points should be the same point. These 2 points become the same point if, as Alex mentioned, the first component equal to the first component and the second component is equal to the second component. So that is the definition, yes? So we say that an ordered pair is equal to another ordered pair if and only if the first component is equal to the first component and the second component is also equal to the second component. So that's the definition of equality of two ordered pairs. Yeah, as simple as that. But then let me just finalize this lesson by the new definition of the operation, Cartesian product. Definition. So I would say let A and B be sets. The Cartesian, this is the French philosopher Descartes, yes? So the Cartesian, he was also a mathematician. So analytic geometry is actually his invention. So the Cartesian product A, you denote it by a cross. B, it's important to put this cross. It is not like numbers. In numbers, it is irrelevant. You can just write AB to mean A times B. But here you have to put this cross for the Cartesian product. The Cartesian product A cross B is defined as follows. So you would say that A cross B is the set consisting of ordered pairs. Let me write it like this, A and B, consisting of all ordered pairs for which the first component is coming from the first set on the left and the second component is in the second set. So that is called the Cartesian product of two sets. Okay, and it is very important to realize that the elements inside this Cartesian product are not of the same type of the elements of each one of them individually. It suddenly becomes an ordered pair. Okay, so let me give you an example, and that is enough for the purpose of this lesson. You don't need to know more about this. So example, I would say that let A be this set, for example, 1 and 2, and B be this set, 2 3, and 4. Determine these sets. A cross B, another one, B cross A, I don't know, for example, A cross A, and finally B cross B. So we want to determine these sets, okay? So A cross B, let me write them in front of them. So A is 1 and 2. This part is not mandatory. I'm just writing everything to be in front of our eyes. Okay, so my goal is to multiply. So multiply is not a good word. I want to find the Cartesian product of A with B. So it means that I need to write all ordered pairs so that the first component belongs to the first set and the second component belongs to the second set. Okay, so it is not hard to guess what to do, because for the first component, how many options are available? I have only 2 options. I can either choose 1 or choose 2. But if I choose 1, for the second component, I have 3 choices, 2, 3, and 4. If I choose 2, I have 3 choices, 2, 3, and 4. So in general, I have 6 choices for making my ordered pair. But it is extremely important that the first component should come from the first set. So it is sensitive to the order. Do you remember that? A intersection B was equal to B intersection A, and then A union B was equal to B union A. Of course, A minus B is not equal to B minus A. That was also sensitive to the order. This is also sensitive to the order. So I will open a curly bracket, then I would write, I will choose 1 from the first one and 2 from the second one. I choose 1 from the first one and 3 from the second one. I choose 1 from the first one and then 4 from the second one. Then I will not have any option available for choosing 1 from the first one. So I have to switch to 2. Again, I choose 2 from the first one and 2 from the second one. I choose 2 from the first one, 3 from the second one, and finally 2 and 4. And these are the only options available. Yes? If I ask you what is the cardinality of this set, you need to understand what to count. Yes? You need to count the number of ordered pairs, because the definition of Cartesian product is the set consisting of all ordered pairs. So each ordered pair is an element of the Cartesian product. So when I ask you what is the cardinality of A cross B, you shouldn't count these individual numbers. You should count the number of ordered pairs. And 1, 2, 3, 4, 5, 6. I have 6 ordered pairs. And then you immediately realize that you're not allowed to write 2 here, because if it was a set, the curly brackets 2 and 2 is exactly the one with 1, 2, because I told you that a repetition of elements does not change the set. So these 2 sets are equal. But the ordered pair of 2 and 2 is just the ordered pair of 2 and 2. You cannot simplify it more than that. So that's the answer of A cross B. And then if I do this B cross A immediately, so this becomes 2 and 3 and 4, and then it becomes 1 and 2. But this time, the first components should be chosen from the first set. So this time it becomes 2 and 1, 2 and 2. And then I go to the next one, 3 and 1, 3 and 2. And then 4 and 1, 4 and 2. If I ask you, are these 2 sets equal? What's your answer? What's the answer?
No,
Yes.
of course not.
Of course not. Because 1 and 2, based on the definition of the ordered set, is not equal to 2 and 1. And for example, 1 and 2, you see it here, but if you look inside, you will never find 1 and 2. So that is enough to say that these 2 sets are not equal. So in contrary to the normal product of numbers, which is commutative, the Cartesian product of sets in general is not commutative. Okay. is in general not commutative. Okay. So here, and then I go to A and cross A. What is A cross A? So it means that I have 1 and 2 multiplied by 1 and 2. So this becomes 1 and 1, 1 and 2, 2 and 1, 2 and 2. I'm writing quickly, but if you think that you don't understand, please interrupt me. And B and B, so let me write it a little bit smaller so that I can put it here. So this is 2, 3, and 4 multiplied by Cartesian product by 2, 3, and 4. So hopefully you realize that you have to have 9 elements, 9 ordered pairs. So 2 and 2, 2 and 3, 2 and 4, 3 and 2, 3 and 3, 3 and 4, and then 4 and 2, 4 and 3, 4 and 4. Okay. Let me test your answer. So let me write these things for you here. So these are not part of the problem. So let me write with a different color. So here, if I ask you what is the cardinality of A cross A Cartesian product B, you would say these two are the same. And in this problem, it is 6, both of them. What is the cardinality of A cross A? It is 4. What is the cardinality of B cross B? If you count them, it is 9. Yes? But let me ask you, if I ask you what is this, can you answer this? What is the intersection of these two sets? Is there any intersection between these two?
0.
No, no. There is no 0, by the way. If you mean empty set, you should say empty set. Because intersection cannot be 0, yes? Intersection of two sets is a set, 0 is a number. If you say the empty set, the answer here is wrong because of one element. Anyone else?
Is it 2, 2? Like,
so how should I write that? Can you tell me how should I write it? Respect everything. You just tell me, I will write it for you. Yes, 2, 2 is correct, but how should I write? Just write, if I write 2 and 2, is that correct?
Bracket,
Yes, curly brackets.
and
then this and 2 in pair of brackets, and then
Okay.
curly brackets closed. Yes, thank you very much. So this is the intersection between these two, because you see that I am finding this element which is in common in both of these sets. So whatever we were able to do with normal sets, we can also do with Cartesian products, because Cartesian products are also sets. So if the union is defined for two sets, the intersection is defined for two sets, the intersection can still be defined for the Cartesian product of two sets. I don't want to disturb you more because that is enough for the lesson, but usually in later lessons, if you go to mathematics, people call it A squared. Okay, A squared, because this doesn't make sense. Because a squared means that I have a number, I raise it to power 2. So what does it mean if I say I have a set, I want to square it? If you see this symbol, it means that you need to Cartesian product the set with itself and get a set. So A squared, whenever you see, it means A cross A. Okay, but let me test your understanding. What do you think will happen? This is not the lesson. So lesson is finished here, actually. Okay, but we have a little bit of time, so let us play around a little bit. So what do you think would be the answer to this? First of all, is it meaningful? The Cartesian product is defined for all sets, for all pair of sets. So A is a set, the empty set is a set. I want to form the Cartesian product. What is your guess?
Would it be an empty set?
Yes, your guess is correct. But can you elaborate that?
Because it has to have a, like the minimum value would be.
No, that is the problem. If you want, there is no minimum. I can feel that what you are in trouble now. Your guess is
because the cardinality should be the cardinality of the first set and the second set, and since the cardinality of an empty set is 0, it becomes 0.
No, but there is no guarantee, because yes, you are right. If I have two non-empty sets, the cardinality of A cross B is equal to the cardinality of A times cardinality of B. Yes, this is the reason. Before proving this, I need to assume that these two sets are not empty, but one of them here is empty. This is exactly of the same nature. Do you remember my demonstration for that the set empty is the subset of every set? Why this is correct? Why the empty set is the subset of any set? This kind of argument that I used here can also be used here. So by the way, do you remember why the empty set is the subset of every set?
I don't remember.
Yeah, the reason was proof by contradiction. Yes. Let me ask you again, because these are important things. Yes. It's good to understand. So when you say that A is not a subset of B, what is the meaning of this sentence? What has happened that you say A is not a subset of B? Anyone?
A found in B.
Pardon?
I'm sorry, Alexander, you can say.
Yes.
It means there is an element in A which is not found in B.
Yes, there exists an element in A which is not in B. Hopefully you haven't forgotten this. Reverse E means there exists an X in A that is not in B. My mistake. That is not in B. When you say that A is a subset of B, it means that whatever is inside A is also inside B. So when you say that A is not a subset of B, it means that at least I was able to find at least one element in A which is not in B. So it means there exists an element in A which is not in B. Now, my claim is that empty set is the subset of any set. If you say no, if no, what does it mean? Then this means the empty set is not a subset of A. But what does it mean? It means that there exists something in this which is not here. But we know that this is not possible because the empty set doesn't have any elements. So this means that there exists an element in the empty set such that this element is not in A, but this is false. So it means that when it is false, it means that I have a contradiction. So if you say this is not the case, you have to admit this false statement, but you cannot admit false statements unless you are a politician, yes? Okay, so this is the reason that empty set is the subset of any set. Now, can you cook up an argument similar to this for why A cross empty set is the empty set? Okay, let me tell you again, but you can help me. So my claim is to show that this is the empty set. I told you this is not part of your lesson, okay? But what happens, I would say if not, so this is if not. If not, then what does it mean? It means that this is not empty. When you say that this is not empty, it means that there is something in it. Otherwise, it is empty. But because this is the Cartesian product, it means that there exists an ordered pair in this Cartesian product. I am claiming that this is empty. If you say this is not empty, it means that when you look inside, you can find something. But because this is Cartesian product, it means that when you look inside this, you can find an ordered pair there. Okay? Now you are telling me that this ordered pair belongs to A cross empty. So what can I conclude? It means that the first component should be in A, no problem, and the second component should be in the second set. But this is problematic. Yes. Because if you admit that this is not empty, you have to admit that the empty set you can find an element. But this is contradiction, yes? So this is why this is the empty set. Hopefully you understand. If you don't worry about that. Can you tell me what is the answer to this one?
It is also the empty set.
It's also the empty set. So even though the Cartesian product is not commutative, but at least for this case, it is commutative. So it is not commutative, but at least for this case, I can write the other way around. So let me just finalize this by just one single remark. This remark is important to remember. But if you don't like these kind of things, you can completely forget about this. You're on the safe side. So remark. So these two remarks I want you to know. First of all is that A cross B in general is not equal to B cross A in general. Even though there are some exceptions, for example, like this. And the other thing is that if A and B are finite, then as you predicted, the cardinality of A cross B is equal to cardinality of A times cardinality of B, if they are finite. Okay, so this remark, I want you to have it in somewhere in your head, but what I told you here is just let me write here, it's optional here. So optional, yes. You don't need to understand that at all. Any questions? Okay, so let me stop this video